Welcome to another edition of Arup K Chatterjee's podcast. So today we are again going to discuss some of the central ideas that we have been discussing over past few podcasts. And the concept that we are going to discuss today, as Professor Arup highlighted last time around, is entanglement. Over to you, Arup.
Thanks, Shobhit. Shudip, I think we were at a very interesting juncture when we left the conversation last. And one of the key notions, key concept that seems like it's very easy to understand, and that seems like it's even easier to use in a conversation in the English language, and that is very, very frequently misused, if not entirely abused nowadays, is entanglement. So,
Yeah.
first of all, do you agree with my sentiments here? Do you feel like there's any iota of truth in what I'm saying? Because I'm not a native of the quantum mechanics world, so I should not pretend like I'm so offended or something. No, of course not. I would love if words take on their own lives, if concepts can enrich people's lives. But my question to you, Shudip, would be: isn't the word entanglement or the concept of entanglement already so complex and so rich? Now, when we bring down the fertility, the richness of concepts like entanglement, aren't we losing out on so much meaning? So, what would you say is entanglement, and what is the acceptable way in which we do not vulgarize the concept of bringing it to other fields of the academia or in to life in general? Is there a way that we can find correlates of the concept of entanglement in quantum mechanics in certain other walks of life?
Okay. Thank you very much. And I will say that this question that you have raised is perhaps the most difficult question that we also face while doing our research, say, in particularly quantum cognition and quantum-like framework. First of all, I'd just like to mention very briefly what entanglement actually means. Certainly, quote unquote means, because this meaning is not clear even after 100 years of quantum foundations debate. It is simply saying that there are certain occasions, there are certain very, very special contexts in which you cannot assign separate identities to subsystems of a system. The system only has a global identity. Say, for example, if these two particles are entangled, physically entangled, I mean, and even if these two particles are taken very far to each other, which are in physics language, it is often called a space-like separation. We can discuss about space-like separation later on, but say these are like taken very far apart. In that kind of a condition, even if we do one particular measurement on one particular particle, then we can gain immediately some information about the property, corresponding property of the other particle. Now, if you come from the perspective of Newtonian physics or even theory of relativity, that seems to be quite impossible, because theory of relativity or classical physics, I should say, wholly depends upon two very important concepts, and these two concepts are separability and locality. So separability means that two different systems which really don't have much to do with each other, they can be taken as to be separate systems. And therefore, doing something to one system immediately should not affect the other system. Otherwise, that will be spooky action at a distance, as Einstein would say. And the other one is localizability. Localizability means that every system or every particle in our discussion, for example, they have a local identity. Local identity means that they are fully described by whatever is happening in their own locality in space-time. But that is not going to happen, or that breaks down when you think about physical entanglement. In physical entanglement, just now as we discussed, there is only a global identity. Global identity means that the particles taken together or entangled system. But if you think about local identities of the particle, that is totally randomized, or that is totally what is called as mixed. So that is why it really doesn't tally well with our intuition. Our intuitive view of the reality is that very much local and very much separate. So you have a local identity, I have a local identity, and we are separate from each other. But what
Hmm.
about this global identity? So that is what entanglement put forward in the table. Now, entanglement, the word entanglement was first of all used by Erwin Schrödinger in
Hmm.
1935. And then later on, it was utilized by various other great minds, certainly Albert Einstein, who didn't accept the philosophical implications of that. Now,
Hmm.
you have very rightly mentioned that this word entanglement has been abused a lot over time.
Hmm. Hmm.
Mainly, in popular science, in science fiction, there have been various kind of misrepresentation of entanglement, so to say. Now, I will say that when it comes to other domains of knowledge, particularly in decision science or in social science or in cognitive science in general, there are ways in which entanglement can be talked about, but we should be very careful that we are not talking in terms of any physicalism. We are not saying that, say, for example, the minds are physically entangled with each other. We don't know about that. We can only talk in terms of information theory. So,
Hmm.
information theory is a more abstract way of looking at entanglement. There have been many interesting experiments which are going on, which says that concepts in our mind, for example, in our brain, if you like to say, they are combined in such a way that they can be taken as to be entangled. Now, this
Yeah. So
entangled or what is known as
this is
concept
where Sudip,
combination. Yeah,
I, I will quickly interrupt you with due apologies and ask you another question. I'll try to
yeah,
smuggle in another one because I think you are on the verge of answering what I already wanted to ask. Uh, now we So I'm assuming that you meant subatomic particles. When you began with particles initially, I'm
yeah,
assuming you meant subatomic particles, which if spaced out, over a long distance, they seem to correspond in their spins in some values,
yeah,
and these values can be calculated or localized in their local environment. So this is spooky action at a distance, according to Einstein. Now, my question would be, what if we say, or can we ask the question simply that is it the particles that are entangled, or is it our cognition of the particles or cognitions of the particles that are entangled? Is this making sense to you? So I am viewing two particles, and these are two different phenomena. Viewing particle A is one phenomena, that is phenomena A. Viewing particle B is another phenomena of cognition, that is phenomenon B. So is it the two particles that are entangled, or is it these two phenomena of cognitions that are entangled?
yeah. I think that's a great question. You see that in standard quantum mechanical representation, it is basically the particles which are entangled. So the particles have so-called non-local correlations. So,
Hmm.
or in other words, you have classical correlation, coming from classical statistics, but you also have quantum correlations, and quantum correlations are exactly what entanglement would suggest. So in standard view, it is basically the particles which are entangled. Rather, Alice and Bob, who are measuring the particles in their own laboratories, they should not be, in some sense, entangled. They should be having free will in some sense, or as it is called as like free choice of measurements. That is one of the criteria for understanding entanglement between particles. This goes back to John Bell's experiment and so on. So not directly that cognition are entangled in this experimental setup. However, I would like to mention that the point where I ended upon is that now cognitive scientists are doing certain interesting experiments about concept combination within one brain or one mind, and those concepts can be combined in such a way that they mimic entanglement in quantum mechanics. That is possible.
Hmm. Great. So I think, Shudeep, one short episode on entanglement certainly is not enough, but time the old enemy is knocking at our door once again, and we will have to end it here. I'm so sorry to say
Yeah,
that. I hate to say these words, Shudeep, but I very much look forward to having you on my podcast very, very
yeah,
soon, maybe middle of the week. And I must thank Shobhit for guiding us on this, for being the torch bearer. Shobhit, thank you so much, and it's over to you.
Yeah,
Thank you,
yeah,
Arup.
yeah.
So I would like to thank Sudip as well for highlighting the idea of, for unpacking entanglement for us, which basically shows that separability and locality that we take for granted, which is our view of the world, is essentially challenged in this notion. And Arup then raised a very important concern, which basically relates to the heart of the issue, wherein the measurement itself cannot be distinguished from the thing being measured when it comes to subatomic particles. So, as Sudeep also highlighted this idea about Alice and Bob, when they're measuring things, it seems as if they are also entangled while they are measuring certain subatomic particles. So, I think this provides us with a field of a lot of opportunities for asking questions in the future and having interesting discussions over the podcast. So, thank you once again.
Yeah,